Welcome to Section 3 of the R Troubleshooting Solutions video series. This section is all about data frames and covers 5 of the most common questions R programmers have about data frame manipulations. By the end of this section, you'll know how to join data frames, how to subset elements from data frames, how to reshape data frames, how to remove columns from data frames, and how to store lists as data frame columns. This video answers the question, how do I join two data frames? In this video, you'll learn about the 6 different types of data frame joins, and about functions from the dplyr package that perform these joins. Let's begin by looking at the 6 main ways two data frames can be joined. For these examples, we're going to use 2 data frames of data from a veterinary practice. The first is a list of owners and their pets. Note that 2 of the owners, Bob and Carol, share a pet named Mittens. The second example data frame is a list of pets and their species. You might have noticed that 2 of the pets in the second data frame, Rex and Fido, don't appear in the first data frame. You might also have noticed that Erin's pet Pancho does not appear in the second data frame. The first type of data frame join we're going to look at is a left join. You can think of a left join as taking each row in A and looking up the corresponding row in B, then adding the matching columns from B back onto A. Because the pet column is the only common column between A and B, this lookup will be performed by matching the values from the pet column. It's also possible to join data frames by matching multiple columns. The result of a left join looks like the original data frame A, with an extra column from B attached. Note that because Mittens appears twice in A, Mittens' species, cat, has been looked up twice in B and added to both rows. Note also that because Pancho doesn't appear in B, his species is given as NA in the join table. A left join will keep all the rows from A, even if they don't all have matches in B. A right join is very similar to a left join, except that A and B swap places. All the rows from the B data frame are used to look up values in A. The joined data frame contains all the rows from B, again with an NA for Pancho's species as before. And once again, left and right joins are exactly equivalent, the only difference being the order in which the inputs are given. An inner join is very similar to a left join. It takes each row in A and looks up the corresponding row in B according to the common column pet. The difference is that while a left join will always keep all columns from A, an inner join will only keep those columns for which a match is found in B. In this case, it means that Erin and Pancho are not included in the result of the join, because Pancho was not listed in B. A semi-join is like an inner join, in that it will not include rows from A if it doesn't find a match for them in B. However, a semi-join goes one step further. It doesn't even include the columns from B in the resulting join. Once again, Erin and Pancho have been removed, but this time the resulting data frame doesn't even have the species column, just the original columns from A. An anti-join can be thought of as the inverse of a semi-join. Remember that a semi-join will only keep the rows from A for which it finds a match in B, and it won't add any columns from B to the result. An anti-join will only keep the rows from A from which it doesn't find a match in B, although, like a semi-join, it will not add any of B's columns to the result. So, in this example, Erin and Pancho are the only row in A with no match in B, so that they are the only row in the result. Finally, after so many examples of joins that remove rows and columns, a full join is the opposite. It's the most generous and inclusive of data frame joins. A full join will include all rows and all columns from both A and B in the final result, filling in with NAs whenever a match is not found. No data from A or B is lost in a full join. Now that we know the 6 most important data frame joins, let's move into RStudio and see them in action. In the source pane on the left-hand side of the screen is some code to load our example data frames, so let's run that code now. To perform the data frame joins, we're going to use the dplyr package. It's possible to join data frames in base R using the merge function, but dplyr provides a set of clearly named, fast, and easy to use joining functions that solve a lot of the common problems and pitfalls associated with merge. So let's load dplyr now. All the data frame joining functions in dplyr follow a simple and consistent naming scheme. For our first example, we'll perform a left join with the left_join function. You'll notice that left join printed out a message to tell us that it was joining by the pet column. dplyr's join functions will automatically detect the common columns between data frames and use them for the join, and they support joining by matching multiple columns. You can also manually specify the columns to join by if you want. Recall that a left join returns all rows from the first data frame, even those that don't appear in the second data frame, which is why Pancho species is given as NA in the resulting data frame. Now let's try the reverse of a left join, a right join. Note that I've reversed the order of the two data frames when calling the function. It produces exactly the same result as the complementary left join. Inner joins are like left joins, but they remove rows not found in the second data frame, like so. Aaron and Pancho are not included in the resulting data frame. A semi-join does the same, but it doesn't include any additional columns from the second data frame. Once again, Aaron and Pancho are missing, but this time we also don't have the third column from B, species. An anti-join returns the invoice of an inner join, all the rows from the first data frame that don't appear in the second, again without any additional columns. Finally, a full join returns all the rows and all the columns from both input data frames, filling in with NAs where it can't find a match.